Welcome back. This is day 3 of evolution, and today we're going to be talking about what theories have developed to explain how evolution occurs. So remember, when you see this word evolution, we're just talking about change over time. But notice that I described evolution as a theory and not a fact. So if you think way back to Unit 1, we talked about the differences between theories and facts. Okay, facts are measurable, facts are observable. They are observations that we can make, but theories are basically how you make sense or interpret that information that you have. So because not one of us has been alive for the billions of years that evolution has been occurring, we can't definitely say, yes, this is how it happened. I saw it all. I was there for all of it. I witnessed it. I observed it. No, we weren't. We didn't, right? So maybe one of these days I'll create a time machine that allows us to go back and double check and make sure we're really right. But until that day comes, we're just running off of the evidence that we have and making inferences about it, right? So we can look at the fossil record, we can look at the similarities between DNA sequences, and we can make inferences about what we know, but we can't call evolution a fact because we didn't actually observe it. We weren't there from the beginning to say this is exactly how it happened. Right, so keeping that in mind, I want you guys to use that information to predict. Say an area that was once a swamp becomes drier over time, right? This was an environmental change. How might this impact the survival of species that live in this environment? Do living organisms adapt to new environments? And how might this change impact future generations? Right, so you've actually got a few questions embedded within this question. So I want you guys to go ahead and pause this video, take about 2 minutes to unpack that, and then press play when you're ready to review it. All right, so let's take a look at this picture on the left, right? This is a swamp. It looks like it's a pretty wet environment, which means we're gonna find lots of aquatic species living there, lots of species that like to live in water. But as that swamp starts to dry, what do you notice about this picture over here on the right? Well, it's a pretty dry environment, which means I don't know if aquatic species are gonna be too happy there. In fact, we're probably gonna find lots of terrestrial species, species that live on land. So what's going to happen over time? Well, let's say a fish that's living in this swamp noticed, oh no, I see that water level's getting lower. In fact, I think I'm going to try to live on land today. I'm going to try it out. We're just going to see what happens. And that fish jumps out of the water, lands on the earth, and it's like, I'm ready to adapt. Is that fish going to survive for long living on land? No, because that fish can't just decide to be a land animal. It can't just adapt. But we have been talking about this word adaptations. And remember that adaptations, adaptations are characteristics or traits that allow an organism to survive and reproduce in a specific environment. Right? Traits that allow an organism to survive in an environment. Right? So while organisms can't necessarily adapt to new environments, maybe, just maybe, they've developed an adaptation, a trait or a characteristic that will allow them to survive in that environment. So maybe through mutations, a few of these fish actually developed the ability to live on land, right? There are species of organisms, like amphibians, right, that can live in both water and land environments. So this was an adaptation that allowed them to survive in a specific environment. So over time, how might this change or impact future generations? Well, we're going to see that those terrestrial species, those animals that have evolved or have those adaptations that allow them to live on land, are going to survive. But those aquatic species, the ones that can only live in water, aren't going to make it. So over time, we'll see a greater percentage of those terrestrial species in this environment and a lower percentage of those aquatic species. All right, so now let's talk about some theories to explain evolution. We've actually got two guys that we need to mention. We've got Lamarck and Darwin. Both of these guys tried to come up with explanations for evolution. And you may notice that one of these men you've probably heard of, and one of these men you maybe haven't. There's a reason for that. We'll talk about that in a second. So both of these guys were sitting around during the 1800s, and they really liked to observe the environment around them. And they noticed as they were watching all these animals, they were like, wow, these organisms actually seem really suited for their jobs and their environments. Like, they're really good at what they do. Like, look at this hummingbird. That long beak that it has, or that long bill, it's perfect for reaching into those plants or those flowers and getting nectar. Wow, it's almost like it was made for that. And so they realized independently, they kind of came up with the idea of adaptations, right? Characteristics that help an organism survive. They noticed, wow, they have traits that are really helpful for the things that they do. But my lights turned off. But as these guys started to observe the world around them, they came up with different explanations for why this is happening, right? But before we get into that, I want you guys to identify the adaptations that we see in these organisms. So if you look around you, you'll notice that basically every animal on Earth has adaptations, right? They all have characteristics that help them survive and reproduce in a specific environment. So you'll see the giraffes, right? Giraffes have got a really long neck that allows them to reach into tall trees and get food. Turtles have got shells that allow them to retreat into and hide from predators. And then even things like these crabs have got a really, really massive claw that allows them to, one, attract mates, and then also burrow holes into the sand that they can hide in. So now Lamarck, as he was looking around, looking at all these animals, he was like, oh my gosh, I figured it out. I understand the secret to the universe. This is what it is, okay? He said, organisms acquire or develop adaptations to meet their needs in an environment. Specifically, an organism can change its physical traits by using its body in certain ways. And the characteristics that an organism acquires during its life are then passed on to offspring. All right, it's sounded pretty good. Sounds pretty intelligent. So let's look at what that looks like in practice. So Lamarck, he said, if a crab notices, wow, it'd be really nice if I had a bigger claw. Like I feel like I could really dig a bigger hole with that claw. It'd be really helpful. Lamarck said, that crab can actually just exercise its claw every single day. And as he does that, it's gonna get stronger, it's gonna get bigger. And then as that crab develops the bigger claw, it can then pass on that trait to its offspring. So all of the offspring that come from this crab are then gonna have a big claw. Now I want you guys to think, is that really what happens? I mean, I'll give it to him. Let's see. Now let's imagine what Lamarck, or how Lamarck would explain giraffe evolution. So according to Lamarck, how did these giraffes get a long neck? Well, he would say that one day this giraffe noticed, wow, it would be a lot better if I could just stretch my neck and reach that really tall tree. And so Lamarck said that giraffe could stretch its neck every day, and every day that neck would get a little bit longer until he could finally reach that tree. And then when he grew up to have children, he would then pass on that long neck trait to his offspring. Now, guys, if you haven't noticed it by now, this is not a correct theory, okay? As much as I would wish to be taller, right? I can't just stretch out my legs every single day and grow taller. And especially even if a miracle happened and somehow I lengthened my legs, my children are not gonna have that trait, okay? It's just simply not how life works. So Lamarck's theory is actually not correct. And he was wrong for a few reasons. So the first reason that you need to know is that acquired traits are not inherited. Only traits that are found within your DNA are passed on. So take for example, let's say you go to the gym every single day. You're like, I'm gonna be buff. Here we go. If you get buff and then you decide to have children, are your kids gonna be born with those muscles that you developed? No, because those acquired traits are not passed on. Only the traits that are encoded in your DNA are what's passed on to future generations. Man, it's raining outside. All right. Now, he was also wrong for another reason, and that is that organisms do not evolve, right? This singular giraffe can't decide, I'm gonna have a longer neck, I'm gonna really work on it, it's gonna be long, it's gonna be great. It doesn't happen that way, right? So organisms do not evolve, populations and species do, though. All right, so that's when Darwin started to come in. He heard Lamarck's theory and he's like, I think you got some good points, but I disagree, man. So he decided this is how he was going to explain evolution, right? He said that organisms born with the best adaptations survive and pass on their traits to offspring. Organisms without these adaptations die and do not reproduce. So over time, the population changes as more organisms inherit that adaptation. This is sounding better. I'll give it to him. So Darwin explained natural selection. Oh my God, it is really pouring out there. Okay. Darwin came up with this theory of natural selection. So he noticed that maybe there was a crab who had a mutation, and that crab was born with a slightly larger claw than the rest of that population. So over time, that crab with the larger claw is going to survive better than his counterparts. And that means that, or more than his fellow crabs. And that means he's going to survive and reproduce more offspring. Now, because that mutation, that adaptation is embedded in his DNA, he's going to pass on that trait to his offspring, which means that eventually all of the crabs in this population are going to have that adaptation. The population is going to evolve or change. Right. But let's say that one day a crab is born with an even larger claw. What's going to happen then? The same thing. So natural selection will continue and the population evolves further. So evolution is constantly happening. Oh my gosh. Well, we're just going to have to. You guys hear this? We're going to power through. Okay. I'm just going to have to talk louder. So evolution is constantly occurring, right? Natural selection is constantly occurring as the environment is going to select for the best traits for that organism, and those best traits are going to be passed on to future generations. So now I want you guys to pause this video and think. We just saw how Lamarck would explain giraffe evolution, but how would Darwin explain giraffe evolution? All right, pause this video, write down what you think, and then press play when you're ready to review it. All right, so Darwin would say that maybe a giraffe developed an adaptation, right? There was a mutation in its DNA that made it have a little bit longer of a neck. So that long neck giraffe is going to have an easier time reaching food, which means he's going to be more well. Offspring are going to inherit that long necked trait, and eventually the next population of giraffes is going to have. It says my connection's unstable. That next population of giraffes is going to have a longer neck, right? And that's going to continue over and over and over. And so giraffes' necks are gradually going to get a little bit longer through every generation. Now, I've got two more things for you guys to do today, okay? On your paper, there are two different theories talking about how elephants have evolved to have longer trunks. I want you guys to choose one of those theories. You can choose either one, either A or B. State whether it determines, whether it demonstrates Lamarck's theory or Darwin's theory of natural selection, and justify your answer with evidence. So again, one of these is going to be an example of Lamarck. One of these is going to be an example of Darwin. You can choose either one. Just tell me which one it is and how you know that. All right, so pause this video, fill that out now. Right, so I'm not going to give you the evidence that you should back up your answer with, but if you chose theory A, you should have told me that that is Lamarck's theory. If you chose theory B, you should have told me that that is Darwin's theory of natural selection. But I still want you guys to justify your answer with evidence. So make sure you tell me why. All right, the very last thing we're going to do today is some true or false statements. So we're going to read through some statements together. And I want you guys to write a T next to statements that are true according to Darwin's theory of natural selection. And I want you to write an F next to statements that are false or that describe Lamarckian evolution. Right, so T for true, F for false. So the first statement says, evolution occurs when organisms adapt to meet their needs in an environment. Well, let's look at this one. We see that organisms adapt. Right, but do organisms adapt? Do organisms evolve? No, right? Populations do. So this one's going to be false. Right, number two, whole populations, not individual organisms, evolve over time based on their environment. I'm seeing based on their environment. Remember, that is natural selection. I think that's true. That sounds pretty accurate, right? All right, number three, adaptations are inherited. What do you guys think? Are they going to be passed down to generations? Yes. If an organism has an adaptation that helps them survive, it's going to get passed on in their DNA. That is true. All right, number four, adaptations are acquired based on use. So think back to what Lamarck said, right? He said that if that crab worked out its claw a lot, it would create a stronger claw and then pass that on to his offspring. Is that true though? Nope, that's going to be a false one. Number five, if an organism is not well adapted to its environment, it dies. That unfortunately is true. And finally, number six, if an organism struggles in an environment, it adapts. Think back to our swamp example. If that fish was struggling to survive on that land, could it just decide, I'm going to adapt, I'm going to become a land animal? No, it doesn't work that way. If an organism is not well adapted for its environment, it's going to die. It cannot just choose to adapt. It has to have an adaptation that allows it to survive. All right. If you got any questions about this, please let me know. Other than that, have a wonderful afternoon, and I will see you guys tomorrow. Oh, and make sure you fill out your exit ticket. Bye, guys.